Okay.
All right. So we got Ryan. You did 40.
Yeah.
Okay. So one thing you should recognize for 40 is that when you what did it go to? 0 to 4, Ryan?
Yep.
All right. You got 1 minus radical u over radical u du. The first step, we ran out of time at the end of class yesterday, but the first step sometimes, nope, back up. The first step should be, do I know the function that had a derivative of this? No. Okay, that's step 1. Do I know whose derivative I'm looking at? Okay, and the answer is no. So second step, is there some sort of algebra I can do to get it into a form that I recognize? And he uncommon denominatorized it. He broke up the fraction because if you had a common denominator, two fractions had a common denominator, you could subtract them or add them and combine. So if they were combined, you can break them apart, bless you, to get something like this, okay? Now, technically, we need to be careful. We write the integral symbol as we're doing the algebra. Now, do we know the antiderivative of 1 over radical u? No. Well, did you? So how did you do that one? Oh, there it is. I see it.
Yeah.
He wrote it as u to the negative 1/2 minus, now 1. We have not done any calculus yet. All of this was algebra work. Okay, algebra work to get us to a point where we can recognize an antiderivative. This, we know the antiderivative of. Okay? We add 1 to the exponent. Add 1 to negative 1/2, we get, careful there, add 1 to the exponent, we get u to the 1/2. And then divide by 1/2. Same thing as multiplying by 2. Minus, what's the antiderivative of 1? Careful. U plus a constant from 0 to 4. U. You couldn't erase it? Was that supposed to be a joke?
I don't know if it's a joke anymore.
So it's easy in?
Yeah.
All right. From there, you plug in 4, you plug in 0, subtract, and you got 0. So look for an algebra step to get you to the point where you recognize the antiderivative. All right? And then Adam. Cosecant squared theta. You're like, oh, I know that guy. Now, we kind of knew it as, we learned, what's the derivative of cotangent of theta? Negative cosecant squared theta, right? So here's what you should be doing the fundamental theorem of calculus without realizing you're doing the fundamental theorem of calculus, right? It's our guess and check process. So if you are doing a problem and you don't know what the antiderivative is, you should guess and check. You should be like, oh, if this is little f, what's capital F? Well, let's check cotangent of theta, because I remember way back in the day, the derivative of cotangent of theta was negative cosecant squared theta. Uh-oh, I don't have a negative there. How can I adjust for a negative? Make this negative plus a constant, right? Do you see how to guess and check at it? That's the fundamental theorem of calculus. The derivative of the antiderivative checks to make sure you get back to the original. Okay? Plugged in 5 pi over 6, plugged in pi over 6, subtracted. What'd you get, Adam? Oh, 2 radical 3. Radical 3 minus the negative radical 3 to radical 3. Questions for Adam? Thank you. All right, which ones have we not done that you asked about? 28? $28 was 3 to the x from 2 to negative 2 to negative 1. All right, as far as things that bother you in this problem, did the 2 to negative 1 bother you? Do you recognize it's reversed? Should we unreverse it? No, it'll work itself out. Okay, you don't have to do anything to it. It'll work itself out. Second thing, does the 3 to the x bother you? Okay, so you should be going back through your derivative rules. I wonder why we should be going back through our derivative rules. Because it tests to make sure we get the right answer. So maybe tomorrow's quiz to force you to remember your derivative rules, whether we like it or not, it's probably a good exercise. All right, so remind ourselves, the derivative of a to the u, where u is a function of x, 3 to the x, 5 to the x, 10 to the x squared. So that's in the form of a to the u. What was the derivative of a to the u? A to the u times ln a times du dx, because u was a function of x. This is composite the way it's written. It's composite. It wasn't a to the x. If it was a to the x, it would be a to the x times ln a times 1. Because the derivative of x with respect to x is just 1. This allows for a chain rule. Okay. All right, let's test your understanding. What if I put this on the quiz tomorrow? A to the 7x, where a is a constant. A to the 7x times ln of a times 7. Because the du dx there was 7. What's the derivative of 3 to the x? Because what if you guess and check? This is exactly what you should be doing as you do these problems. Don't be lazy. Don't say, I don't remember. We'll go over it tomorrow. The more you push yourself to what was that? Guess and check. Okay? Well, the derivative of a to the u was a to the u times ln a. Okay, so what if I start off by guessing just 3 to the x? Is that a fair guess? Okay. I'm sorry. Here, hold on a second. Back up. Ready? This is little f of x. If I'm guessing at an antiderivative for capital F of x, if I guess at 3 to the x plus c, that's a guess. How do I check it? Take the derivative. Okay. A to the u, 3 to the x times ln, careful, 3 times 1. I guessed, I checked, and what am I checking? What's up? That. Yeah. I'm checking to see if this matches this, because the derivative of the antiderivative should be this. Correct? Is it? No. Is it close? What is close? Well, it's off by a constant, isn't it? Isn't ln 3 a constant? I don't want that. I don't want the ln3. This one doesn't have an ln3. What could I put in the original to not have an ln3 in its derivative? How about a 1 over ln3?
Could you just put the whole thing over ln3?
Yeah. Well, constant multiple rule. If there was a 1 over ln3 in the original, it goes along for the ride. Guess what? I guessed, I checked, I adjusted for a constant. Do I have the correct antiderivative now? Yeah. It's 1 over ln3 times 3 to the x plus a constant from 2 to negative 1. Plug in negative 1, plug in 2, subtract. Okay? That one's going to get a little messy. You could leave that in its ugly form if you really wanted to. All right. Nick.
What do those brackets mean again?
That means I've taken the antiderivative, but I haven't plugged anything in yet. Because what I saw not as much in this class. What I saw earlier, don't write this down. I saw people doing this. Okay. That's wrong because it's like back in geometry. Like I explained this yesterday, but it's like back in geometry when you're solving a Pythagorean theorem problem and you square root both sides and the square root of 64 is 8, but you keep a square root symbol over the 8. No, the square root of 64 was 8. You don't leave the square root symbol. You've already done the square root symbol. You don't leave the integral symbol. You've already done the antiderivative. Just a right bracket reminds me that I've taken the antiderivative, but I haven't plugged anything in yet. It's like the intermediate step. If you want to go through, if you want to keep writing, some people have gotten in the habit of doing, capital F of x is 1 over ln3 times 3 to the x plus c. Then they do capital F of negative 1 and they show their work, and they do capital F of 2 and they show their work, and they subtract. That's fine. This is just another way to show that.
So you don't need to do like the brackets.
You don't have to. You need to know it though, because the test writers on some of the rubrics will show it that way, and we have to recognize it. Good on that one? Was there any other ones you guys wanted to talk about?
30.
30, just, which one?
38.
38. All right, 38. All right, I'm not going to go through the whole thing, but I'll get you going. All right, 38 was the integral from 0 to pi over 3. 4 secant x times tangent x dx. Okay, you should look at this and say, do I know whose derivative looks something like this? Well, yeah, the derivative of blank is secant x tangent x. The derivative of secant of x is secant x tangent x. So secant x plus c. But wait a minute, there's a 4 out front. So what should be here? 4 out front, right? Wait a minute, why didn't I divide by 4? Well, the 4 was already here. If there wasn't, the last problem I had to adjust for a constant because this thing didn't have a constant that came from the derivative. And that's hard to explain. The ln of 3 got put there because of the derivative of 3 to the x. But this thing didn't have it there, so I wanted to get rid of it. Here, I want the 4 there. I don't need to get rid of the 4. I want it there. I need to put it in to the antiderivative so it stays with it when I get to here. That's called adjusting for a constant. That's why all year I've said the constant goes along for the ride. Okay? You plug in pi over 3, you plug in 0, you subtract it. So you guys can take it from there. All right? Questions? All right. Did you understand the dirty rule yesterday? I'm going to explain it again.
Little run through. Little run through.
We'll run through? All right. Really, really, really listen. I'm going to explain it in a different context. Hopefully it makes sense. Okay? It's going to help you with your worksheet that we're going to be doing today. Tonight. We've done this before. Ready? I'm filling a tank with oil. The tank already has 50 liters of oil in it. Okay? 50 liters of oil. I'm not telling you whether I'm starting at time 0 or at time 2 or at time 3. Okay? It has 50 liters of oil in it. Now, you would want to know, I mean, if you're going to be asked how many liters of oil are in it when t equals 3 minutes, 3 hours, 3 seconds, whatever it is, wouldn't you need to know what the time was where the 50 liters of oil were in it? Okay, so here we go. Ready? At t equals 2 minutes, there are 50 liters of oil in the tank. And then I give you a rate function of liters per minute. Liters per minute. How would you find out how many liters of oil were in there at t equals 3? Let's just talk about it. At t equals 2, there's 50 liters of oil. And then I give you a rate function, liters per minute, and I ask how many are in there at 3 minutes.
When you plug 3 into the function.
3 into the what?
Into the function.
The rate function?
Yeah.
Okay. And then do what? So that would give you at t equals 3 into the rate function would be at 3 minutes. It'll tell you how many the rate of change of liters. So the liters per minute rate is. So maybe it's 10 liters per minute at 3. But what if I want to know how many liters are in the tank at 3? Are we ready to answer that, or do you need me to break it down a little bit more? Who needs it broken down a little bit more? Okay, another example. You drive back to your driving activity. I told you that's going to be kind of one of our things we go back to. We have to have some concrete thing to go back to that's easy to understand. All right, let's pretend your driving activity was a straight line drive from your house, okay? But you didn't start the activity until you were 2 miles from your house. And I don't want the 2 to get confusing. 5 miles from your house, okay? You started 5 miles from your house. Then you drove, recording the times every 10 seconds. You drove 17 miles. Where are you at the end of the drive? How far from your house? Okay, you started 5. You drove 17. Right? You're 22 miles from your house. Second question. How many miles did you drive? I've already answered this. How many miles did you drive during the activity? 17, right? So 17 would be your displacement. 5 is where you started. What calculated that 17 though? Because that was a rate, right? The rate function was your miles per hour. Wasn't it the area under that rate function? We use Riemann sums.
We use integral.
Yeah. So if I say, what's your position? Isn't your final position? How many? I said 5 miles from where your house to start. Was that right?
Yeah.
Wasn't it 5 plus the integral from and I didn't give you guys any times, but the times were, I don't know, 0 to whatever, okay? Time 1, time 2 of your velocity function. Doesn't this give you your final position? Do you agree with that? Okay, back to the other question now. Ready? At 2 minutes, you had 50 liters of oil in the tank. I gave you a rate function, not miles per hour, not velocity, a liters per minute function. How would you find out the number of liters of oil in the tank at 3? 50 liters plus 2 to 3 of whatever the rate function was called, right? L prime of t dt. Does that make any sense? Ready? What's this part? They're going to ask you this. Give the meaning of this. It's the, don't talk area, application. It has a meaning here. When I did the driving activity, I didn't walk around and say, what's the meaning of your final answer? And you didn't say it was the area under my velocity curve. Nobody in here said that was the area under my velocity curve. It was what? How many miles you drove. It was an area, I agree. It was how many miles you drove. What's that? What's the area under L prime from 2 to 3? How many liters of oil entered the tank from 2 to 3? Plus whatever you started with. So let's say 10 liters of oil entered the tank from 2 to 3. 10 liters of oil. How many liters are in the tank at 3? 60. Okay. You start 5 miles from your house. You drove 17 miles. How many miles are you from? You get the point? Okay, make it something simple like that. All right? Now you're ready to understand this. Okay, we called it the dirty rule yesterday. It's really not that dirty. All right, it's just kind of, you have to think of it in a different way. We're going to solve the same problem 2 different ways every time. And it feels annoying and tedious, but you have to understand it both ways. We have been doing this way ever since before Christmas. Given dy dx is 3x squared plus 4x minus 5 with the initial condition of y of 2 is -1, find y of 3. Here's how we've been doing this, okay? Antiderivative, y equals x cubed plus 2x squared minus 5x plus a constant. Do you agree with that antiderivative? What was our next step? This is the traditional path. What was our next step? Plug in 2 comma -1. This is a point on the original. This is 2 -1. -1 equals 2 cubed plus 2 times 2 squared minus 5 times 2 plus c. Math, math, math. C equals -7. So y equals x cubed plus 2x squared minus 5x minus 7. That's a position function, right? How do I find out what y of 3 is? Plug 3 into that function. That's the path we've taken for a long time. That should be comfortable to you, all right? The fundamental theorem approach is a little different. Tell me if this makes sense. This is called method 2 on this worksheet that we'll get to in a little bit. Method 2. The integral from a to b, this is not called f. If this were called f, this would be capital F of b minus capital F of a. This is called f prime. Well, the antiderivative of f prime is f. F of b minus f of a. Okay? Well, we're doing the same problem another way. dy dx is the same as y prime. The integral from 2 to 3 of y prime dx is y of 3 minus y of 2. Now, here's the thing. Do you remember yesterday when we did that example problem? It was tangent of t dt, and we made the lower bound 3 and we made the upper bound x. Do you remember that? Why did we pick 3 for the lower bound? Well, the point we were given was like 3, 5, I think it was. 3, 5. Doesn't it make sense to use the value you're given? Because guess what? That's the value you know you're starting with. And then your accumulated amount, you can then calculate where you end up. Because you need a reference point of where did I start? You see the application to the oil problem. Tell me if this makes sense. Y of 3, this is y of 3 minus y of 2 using the fundamental theorem part 2. Antiderivative, plug in 3, plug in 2, subtract. Everybody good with that? What was I trying to find in the first problem? Evaluate y of 3. So isn't this what I'm going to solve for? How do I get y of 3 by itself? Add y of 2 to the other side. Okay. Y of 2 plus the integral from 2 to 3 of y prime dx equals y of 3. What's y of 2? Let's go back up. Ready? Yep. Y of 2 is negative 1. Negative 1 plus the integral from 2 to 3 of y prime dx equals y of 3. Now this part you're going to solve the same way we did before. Antiderivative, which was the cubed function and the quadratic, and then that whole thing. Plug in 3, plug in 2, subtract. What does this part mean? And I didn't use 2 and 3 by coincidence. The area under y prime from 2 to 3, I wasn't given any units. I wasn't given any context. I don't know if it's oil. I don't know if it's miles. I don't know what it is. But what's the meaning of that part of the problem? The integral from 2 to 3 under y prime. Yeah, which is the displacement or the number of liters of oil that have been added during that time period. But what do I have to add on to that? How many I started with. Ready? Negative 1. Isn't that what I started with at 2? And then from 2 to 3, I add on or take away a certain amount? Doesn't that tell me where I end up at 3? Do you get it? Be honest. This is what we called the dirty rule yesterday. It's just another way to set up the same problem, not because we have the choice to. Trust me. There are going to be times where you have to type, like this one I can check because I actually know the antiderivative of 3x squared plus 4x minus 5. There's going to be times where I don't know the antiderivative, and neither does my calculator, but it can evaluate this expression right here. So you're just going to type it into the calculator, okay? You're going to type it in and know that that's the correct setup to get there. You don't have a method 1 as an option. You have to do it this way. This worksheet is a publication that the College Board put out as a hey, this is kind of a big topic. Students struggle with this. Here's a resource to practice. Okay? So we're going to spend some time with it. All right? Does that process make sense to you? So you have -1 plus the accumulated amount. You get 23 that way as well. So next one. I don't know the antiderivative of sine of x squared. This is a perfect example of what I've seen on the AP test. Okay. What if oops, that's the wrong one. Hold on. There we go. F prime is sine of x squared. F of 2 is -5. Find f of 1. Let's do this one together. This will be our last one, and then I'll talk about the quiz tomorrow. Okay? The integral from blank to blank of sine of x squared dx. Can you guys read that at the back? F of 2 is -5. Find f of 1. What should I make my bounds? 2 to 1 or 1 to 2? Do you guys agree or disagree? Let's see, all right? If we do 2 to 1, then, and this is called f prime. What does that equal symbolically? Because I don't know the antiderivative of that. Right? Neither do you. F of f of 1 minus f of 2. What am I trying to solve for? Find f of 1. Okay. It looks good so far. How do I solve for f of 1? Add f of 2. Okay. F of 2 plus the integral from 2 to 1 of sine of x squared dx equals f of 1. Do I know f of 2? Yeah, f of 2 is -5. -5 plus the integral from 2 to 1 of sine of x squared dx equals f of 1. You would type that in your calculator, and it would give you the correct answer. It doesn't know the antiderivative, but it will give you the correct answer. Now, they solved it the other way. They went from 1 to 2. Ty, I think you're good. If you set it up this way and you do it correctly, you're going to get the right answer. It's just an additive inverse. Right?
You can do that over there.
Yeah, you should be able to do it the other way. I haven't done it this way. It should work. Yeah, because here's what's going to happen. Okay, perfect opportunity. I hadn't thought of it this way until now. Do you see how they did -5 minus the integral? But theirs is from 1 to 2. How can we make this the correct order? And we have to do what out front? Opposite, and we end up getting what they get. So our calculator will recognize this and say, okay, I'll do it the way you want me to do it, but I'll account for that opposite sign. It already takes care of it. Either way, it's fine. Did that make any sense to you guys? Okay. So I started at -5. I was displaced the integral amount, and that tells me where I end up. Okay. All right. So this is linked on Canvas. Your assignment is to do 1 through 4, just 1 through 4. And you'll notice numbers 1, 2, and 3, it says by both methods. Number 4, you're just using your calculator. Okay, just the way we just did it. Just use your calculator once you get to that after the setup. I want to see the setup and then use the calculator to solve it. All right, take out your formula sheets that I handed out yesterday. Did everybody get one of those? All right, the derivatives at integral side, all of the derivatives are, did I mark on yours though. Did you mark on yours? All of the derivatives are fair game. Here's what I will say. Look at number 9. They use u primes instead of du dx's, okay? What's the derivative of ln of u? How we learned it. 1 over u times du dx. They put the du dx in the numerator, and they call it u prime. Okay? Our book does not have a great resource page like this. This is the best I could find. All right? It's just the Newton notation instead of the Leibniz. So, do you agree? Number 9 is the same as 1 over u times u prime. 1 over u times u prime. Where u prime is, du dx. So anywhere you see a u prime, you can replace it with a du dx if you really want to. You can. Number 8 is not fair game for tomorrow. I guess that we didn't do Gauss value. All right, into the integral ones. All right. I guess the easiest way to do it is to eliminate some of them. Don't worry about number. Let's go in the first column. You don't have to worry about number 7. Don't cross them out because we'll get to them. 7. You can eliminate 11, 13, 19, and then in the even column, number 4 is just a power rule. Do not cross that out. That's just an add 1 to the exponent, divide by the new exponent. Don't get freaked out by that one. All right, you could in that column you can eliminate 10, 12, 18, and 20. Now, I may do some matching. Like I may take all of the trig functions, sine, cosine, tangent, cosecant, cosecant, cotangent, and do all matching with those ones, with some distractors in there. I may take antiderivatives. I may take some of these and put those as multiple choice. I'm trying to do it on Canvas. If it doesn't work out, it may be paper and pencil, but it's kind of tedious at this point. I'm trying to do my best. All right?
Thanks for that. On Canvas. Here's something part of the first format.
Watch, we're gonna get the quiz tomorrow. I'm just gonna do it on purpose.
Have a good one.
You too.